So these tools were like initially funded and bootstrapped by the EkStep Foundation, and now it's part of the METI infrastructure. In the agenda, like we'll cover the mission of Bhashini that we have, I think, covered effectively in the morning sessions. And we'll also just quickly go through the need for digital infrastructure. And also like I'll quickly touch base on NLTM architecture and basically like the need for effective data sets and models for getting like an quality apps around the Indian languages. And I'll play like a quick video of Ulka, like that covers how to submit data sets and models. And also like we'll just quickly touch base on the roadmap for these tools as well. Yeah, so I think in the morning session, like most of the members covered well on the mission of Bhashini as such. So it's basically to break the language barriers and make the contents and the knowledge available in the Indic languages. So again, like, yeah, I think this is kind of like a trivial thing, right? So data sets, quality data sets like affect the quality of models. And then, I mean, in turn, like it affects the quality of the apps that's built around it. It's kind of like garbage in, garbage out, right? So we have to make sure like quality data sets are built for building effective apps around the ecosystem. Now coming to the NLTM architecture, which was envisioned a couple of years back. So we have like various layers. The first one is the NLTM cloud, which is kind of like an infrastructure layer. And then comes the digital public good, which comprises of Ulka and the other benchmarking and the APIs exposure that could be done for the reference apps. So again, like Ulka, like currently it's part of the datasets, models, and the APIs overall. So how do we just mention that in simple terms? So we have the public here. We're going to contribute for the datasets. And again, that goes into the models, and in turn, it helps with the creation of application, which can then be used by the end users. So you can see like a cycle, right? So once, as Mitesh or Pratyush mentioned, so over time, like we improvise the quality of the entire cycle. So coming to the data sets and the contributors. So with respect to contributors, like we'll just briefly cover the crowdsourced version of it, which is called Bhashadan, which was, touched at a high level in the morning session. So again, like it's crowdsourced. So probably like what you can do is you can just try to access through, I'll just paste a link. So you can just try your hands with some of the things there. So the other thing is like how we can collect the data sets. That's through dedicated team, which comprises of language experts. So I'll cover in the next section of the presentation. Coming to the data sets, I think most of them listed there are trivial. So the first thing is parallel corpus, which constitutes like records available in multiple languages. And the next thing is like monolingual, which is basically like tokenized sentences across various languages. And ASR is for speech to text, and the next one TTS, text to speech, and OCR, and many more. There could be some specialized data sets like multilingual, multi-speaker kind of things as well. And just coming to the Bhashadan platform, it's again like a crowdsourced version of it. So probably like I'll briefly play a video after this one. So it comprises of 4 sections. Basically, first is Suno, which helps in the creation of ASR datasets. So basically, like you get played on audio and you have to convert that into text, or a reference, a mapping would be given. So you have to validate those. Next is the Bolo one. So you'll be given a reference sentence in the language that you might have selected, and you have to speak the respective sentence. And Lico is you'll be given a sentence in one language where you will be asked to translate or validate. The final one is Deco, which is like an image provided. So you just have to do the corresponding mapping in the respective language. I'll just play this video.
National Language Translation Mission, or Bhashini, is a unique initiative by the Government of India that will enable Indians to access all digital content and services in their own language. To achieve this vision, the mission has launched Bhashadan. Bhashadan is a crowdsourcing tool where citizens can make their contributions in their own language in the form of speech or text. The platform can be accessed in multiple languages and you can make your contributions in your own language or any language of your choice. Come, let's understand how the platform works. Suno India. Through Suno India, you can contribute by listening to the audio presented to you in your chosen language and then validating its contents. In case you find that the audio does not match the text, you can contribute by correcting the sentence.
അങ്ങനെ ആകുമ്പോഴേ ഈ ഓരോരുത്തരെയും മാറ്റി നിർത്തേണ്ട ഒരു ആവശ്യം വരില്ല.
Bolo India. Through Bolo India, you can contribute by recording in your own voice the sentences that have been presented to you in your chosen language.
भारतीय अर्थव्यवस्था उच्च विकास पथ पर अग्रसर है.
Likho India. In Likho India, you will have to select a language pair. Once selected, you will be presented with sentences in the first language and their corresponding translations in the second language. You can contribute by validating if the translations are correct or not. Dekho India. Through Dekho India, you can contribute by reading the images presented to you in your chosen language and validating if their corresponding transcriptions are correct or not. During your journey with Bhashadan, you shall earn Bhasha Samarthak badges for your contributions and validation. You shall earn different badges for making a specific number of contributions and validations towards different languages. Whatever badges you earn shall be stored in your profile. Start your journey of becoming a Bhasha Samarthak today. Come, join Bhashadan.
Now coming to the A models, so I think again like the trivial slide here. So it talks about task types and the contributor and the models, right? So when we mention about the task type, like the model specific, I mean, it's tuned to do a specific task. Again, like it could be translation, ASR, TTS, whatever it is. And again, coming to the contributors of A models in Ulka. So we have like various teams listed here to get started with, and there are many more to this list, starting from EkStep, A for Bharat, IITs, and triple ITs. And the models currently we have in Ulka, like it's constitute Indic Trans, Vakyansh, Indic XLET, Indic TTS, and Anuvad for the respective task types. What is Ulka? So we briefly talk about in the architecture diagram, right? So that was the layer which constitutes the data sets, models, and the APIs respective to it. So it's an open scalable data platform. So technically it's not just a tool, it's like a platform by itself. And it's like the world's largest Indic language data set and model platform. And, so yeah, so by now I think most of the teams here might have contributed one thing or the other, either with the A for Bharat or IIT Madras or IIT Bombay, right? So everybody have already contributed. So I think you're familiar with the process as such. And again, like it's coming to that. So there was a big emphasis on the benchmarking. So I think since we had talked about a data platform and language, like I'll just skip that and that will go to the benchmarking. So there was a big stress on having like a quality benchmark here. So that's why like we make sure like there's a paper behind it for any submission that's made to the Ulka platform as such. And coming to the current stats, so if you want, you can just go to the Ulka page right now and see the current status. But yeah, it's mostly updated here. So it contains like 215 million parallel corpus and 14K hours of audio recording, 2.5 million images for OCR. And also like from last week, we have just crossed like 13 million transliteration pairs. So it's fairly accurate with respect to the numbers there. And also like with respect to models, they are closer to like 240 state-of-the-art models across various types. And coming to the benchmark, like as I mentioned, there's a big stress on this one, and we have closer to 135 open benchmarks. That includes the latest one from Facebook as well, which is like Flores 200. So what are the actions supported in Ulka? So as part of datasets, you can do a submission, contribution, my search and download. So it shows all your previous searches so that it's easier for you to download the data. So as of now, we are still not finalized the data policies. So only the government data is coming up now. And with respect to models, like you'll be in the public page, we'll still be able to do explore models and try model. And once you have a signed in version, you'll be able to submit and view all your contribution. So I'll just quickly walk you through the page in a while. And also like with respect to benchmark datasets, benchmarking process, we have the metrics. Again, like in the try model, like there'll be scores under each of the model, and you can see what are the benchmark runs we have done against a particular benchmark data set. And also like as I mentioned, there's a leaderboard for that. Let's say like it could be of any domain, so it could be healthcare or so. There's a domain tagged with the benchmark data sets, so you can just select the particular benchmark data set, select the language, and then view the corresponding leaderboard for that. And there's an option for providing model feedback as well that I'll quickly show. So if you just, so maybe if you want, you can just open in your mobile browser and check it. So if you just go to this bhashini.gov.in/ulka, you'll land in the intro page. So all the things that I mentioned with respect to the metrics, you can just quickly see here with this model. And if you just click on any of the things, you can just see a breakdown of this one, of the languages available, and also like the benchmark data sets, you can see what are the things submitted. And there's an option for filtering by domain and submitter as well. So as I mentioned, like all the popular ones are already integrated with respect to each of the task types. And you can just quickly go into Ulka models page, and here you can see all kind of models available under that particular section. So maybe like I'll just quickly play a video just so that like it covers all the inference across each of these types. Before you watch this video, there's a link in the description which talks in detail about the introduction of Ulka and what are the features available in the public links, meaning what you can actually access without logging in. By this time, I believe you might have already have an idea on what Ulka is. Maybe we can quickly revisit it. Ulka, which stands for Universal Language Contribution API, developed by MITI, is a standard API and open scalable data platform for datasets, models, and benchmarking for Indian languages. Ulka will help researchers develop language AI technologies including machine translation, automating speech recognition, and optical character recognition in all 22 Indian languages. Now let's jump into the Ulka sign up page. It's a simple interface, and we just have to enter very basic information to get started. Once you initiate the sign up by providing name, email address, and password, you would be receiving a confirmation email. Once you confirm, you are good to sign in and explore more features in Ulka. Since I have already created an account, let's log in and start exploring the features. So we land in the dataset overview page, which gives high-level information about the distribution of data. These visuals are already discussed in the introduction video, so we will skip this and jump into the page from where we can contribute our dataset into the Ulka system. We have to navigate to the dataset tab and then select Submit Dataset. The system accepts a name which is user defined, but make sure it's meaningful. Also enter the public URL of the zipped version of the dataset. We will see what this zip contains in a while, but let's copy paste the URL and the name, and once you submit, a service request number is generated and it's a async process. The status would be updated under the My Contribution section as it progresses through various stages all the way from download to publish. So there are 4 different stages in the pipeline. First, the download stage, where the zip file is downloaded from the public URL and unzipped. Next is the ingest stage. It's where the schema validation happens based on the contract, and each of the record would be sent for the validation stage. In validation stage, all the records are validated for canonical checks, and it also passes through a profanity filter. Then in the publish stage, the deduplication happens, and finally the successful records are available in the Ulka system for everybody to consume. Here, as we can see, all the stages have completed. We can see some job level metrics and shows the success and the failure count of records at each of these stages. There will be 2 types of error details available for a job run. First is the error summary, where we can get an aggregated view by error message. This would be very useful when the number of rejects are higher. Here we are downloading it for our current run, and let's quickly walk through this. We can see that some of the records are rejected due to various reasons at the validation stage. Either it could be due to availability of offensive text, or it could be that the records are very short, something like having less than 3 characters in the source sentences in case of parallel corpus. The canonical check depend on the dataset type. We also see that the deduplication check happening in the publish stage, and some of them have been rejected as duplicates. Now, if we want to check the record level details for these errors, we can download the detailed error logs. Now let's download and quickly see what's in there. First, we unzip the error log, and we see that the size is usually much higher, since the respective entire JSON records are included here. For all the error messages, we have corresponding record level information. Let us jump back to the My Contribution tab. Here we have a list of all my past dataset submission details, irrespective of the dataset type. We can use available filters to search for a particular dataset type or status. We can also use the global search to quickly search for any string. Let's assume I want to see all the PIB dataset that we submitted. I can search for the PIB string, and here we can see the result. Now let us review what files are available in the submitted zip. We are currently in the GitHub page for Ulka. As explained in the README, a zip would contain 2 files, namely data.json, which contains the actual data, and the params file, which contains the metadata information. In addition to it, the zip also contains other media files, audio files in case of ASR dataset, and image files in case of OCR dataset. There is a contract defined for each of the dataset types. The link for this contract would be published in the description part. The Ulka GitHub hosts samples for most of the use cases. Let us now check a popular method for creating a parallel corpus, which would be a web script and aligned using labc. Let us now check its params file. Most of them are straightforward. There is a dataset type field which is parallel corpus in this case, and we define the source in the target languages. Then we mention the collection sources, which contains the list of actual sources from where this parallel corpus was curated. We can also provide collection details, but this is an optional field. Then is followed by the license and the submitter information for this submitted dataset. We highly encourage you to fill this params file with as much data as possible. Also, make sure it sticks with the Ulka contract. Some of the fields are predefined as a enum, and the specified value should be one among the list. One such example is the license field, so when specifying, make sure the value is one among the supported licenses. We cannot stress more on providing credits to all the members who had worked on a dataset under the team section. Now let's check the data JSON. This contains the record level information. In case of parallel corpus, the source and the target text are specified. These are the mandatory fields, and if there are any fields specific to that record, they can be included, though they are optional. As a good practice, the default of the common fields can be specified in the params JSON, and the record specific fields are mentioned in the data JSON. Once these two files are created, zip these and make it available through a public link, either GCP or S3, which can be later submitted into the Ulka system. Now that we have seen how to submit a dataset, we'll have a follow-up video on how to contribute a model to Ulka and perform a benchmarking on it. So this is how we submit a model to Ulka. So basically, for dataset, the data sits in the Ulka platform. For model, what we are doing is it's in the submitter's infrastructure, and through Ulka, we are able to infer that. About including the benchmarking. One important thing. So basically, you just go to a model and do submit model, and we upload a JSON in this case, which contains just the basic information on the inference endpoint and also the request response format of it. To note here, models are not actually hosted in the name. I'm just skipping some of the model submission. For the model to be submitted. Version field helps to track the incremental updates to a model. So this section basically talks about the various metadata that we have to fill in. So the ones highlighted in that red star indicates those are the mandatory fields. So once we have all these basic information filled in, you can just go ahead and submit that model. Yeah, so this is like a sample JSON. So if you see here, it talks about the inference endpoint there, and it specifies the request response format. Before you watch this video, there's a link in the description which talks in detail about the introduction of Ulka and what are the features available in the public links, meaning what you can actually access without logging in. We also have a separate video on how to submit datasets to the Ulka system. In this video, we will see the process of contributing a model to Ulka. From the introduction video, we might have understood the meaning of a model and the purpose of model benchmarking. One important thing to note here, models are not actually hosted in the Ulka system. Rather, it makes the models which are already hosted in any environment to be discovered and inferred via Ulka. Now let's jump in. We have to navigate to the model tab and then select submit model. The system accepts a name which is user defined, but make sure it's meaningful. Then we have to upload a JSON containing the details of a model, including the inference endpoint. Before we actually submit a model, we will quickly walk through the contents of this JSON file. The contract of the model submission is available in Ulka GitHub page under the specs folder. Now let's jump to the Swagger view of the contract. Most of the fields might overlap with the ones that we already saw during the dataset submission. We will quickly go through the list of fields. Again, whatever is marked with a red star indicate that it's a mandatory field. Coming back to the fields now. Name denote a meaningful name for the model to be submitted. Version field helps to track the incremental updates to a model. Description field gives a brief information about the model and its goals. Next is the ref URL, which is either the GitHub link or the URL giving further information about the model. The task denotes the category of model under which it has been released or trained. For example, a model could be built for translation or ASR. Languages field specifies the source and the target languages for a model. In case of some task types like OCR and ASR, target language might not be relevant and should be ignored.
license, domain, and submitter are self-explanatory. Now, coming to the inference endpoint. This is a critical object which specifies the callback URL and the schema of the request response for the inference. The callback URL is the actual URL where the model is hosted and can be used for model inference. Then, based on the task type, the inference schema is defined. I guess this is much easier to understand with an example. Now, let's jump into the GitHub link that contains the samples for the model submission JSONs. Now, we are looking at the translation model built for Bengali to English. A proper name, version, description, ref URL, task type, languages, license, domain, and submitter are specified here. Now, under inference endpoint, we see that the callback URL is specified. Before submitting the model, make sure this URL is tested with Postman for appropriate request and response. One more thing to note, the request and response are validated during the model submission. The submission succeeds only if the endpoint is reachable and can successfully respond to the specified sample input. The last is the training dataset object, wherein we can specify what kind of dataset we have used for training the model. If the training dataset was used from Ulka, feel free to mention that in the dataset ID field. Now that we have seen the contents of the JSON, let's go ahead and submit it. Let us consider a meaningful name and upload a respective JSON file. Once you submit, a service request number is generated and it's a async process. The status would be updated under the My Contribution section. It would initially be in the unpublished stage. We can either run a benchmark if a respective benchmark dataset is available and then publish it, or we have the flexibility to publish a model without benchmarking. Let us now understand the benchmarking process in detail. Assume we had already submitted a model. The next step is to see its effectiveness. The effectiveness or efficiency of a model is defined as benchmarking, which is usually done against a standard golden dataset with an universally accepted metrics for a particular task type. For example, let us pick up a model, say Anuvad Translation English Hindi. Here, as we can see, we had already run a benchmarking using the Flores dataset, which is one of the standard benchmark dataset, against the metric blue. Now let's run a new benchmark run. So we click on Run Benchmark button. Since we had run the benchmarking on Flores dataset using blue, the option to select would be grayed out, meaning we cannot rerun a completed process for the same dataset metric combination. So let's select a different benchmarking dataset, say WMT20 dataset, and select the metric blue. Let's submit it now. The benchmarking process starts in the background and the status should be changed from in progress to completed once it's done. Now we have completed a few benchmark runs against this model and we can see their respective blue scores. Since we are happy with the results, let's go ahead and publish this model. Okay, now that we have published the model, it would now be visible to all. Let's check the Explore Model tab. Let us search for English Hindi and select the model. If we scroll down, we can see all the benchmark runs along with their respective scores. Now that we have completed benchmarking runs for different models against different dataset and metrics, the final section would be to cover the leaderboard, wherein we can have a view of top performing models against a specific dataset and metric. For that, let's jump into the benchmark dataset tab and select any benchmark dataset, say Flores English Hindi. Now we can see all the models that were run against this dataset grouped by the metric. and we see that they are ranked based on their respective scores. With this, we have seen how to contribute a model to ULCA and also how to perform benchmarking against these. More features are coming in, so please stay tuned.
Coming to the actual try model, like this briefly talks about it. So this is the translation model inference.
इसको हम इस प्रकार से समझें कि जैसे मानव शरीर एक है, किंतु उसके प्रत्येक अंग प्रत्यंग का अपना एक कार्य है और उस संपूर्णता में उसका अपना योगदान है। यदि कोई एक अंग कार्य नहीं करता है ठीक से, तो उसका प्रभाव केवल उस अंग तक सीमित नहीं रहता है।
So we see that it's kind of like real time. So as we speak, like it starts to infer.
एवं विधं सुखं कुतः लभ्यते इति वयं न जानीमः। सामान्यतः वयं चिन्तयामः सुखम् अर्थात् अनुकूलं संवेदनं, दुःखम् अर्थात् प्रतिकूलं संवेदनम्।
This is TTS inference.
कई लोगों ने फरवरी की शुरुआत में कई हार्डवेयर इस्तेमाल करके खोज की पुष्टि की है और मंगलवार को इसकी घोषणा की गई थी।
कई लोगों ने फरवरी की शुरुआत में कई हार्डवेयर इस्तेमाल करके खोज की पुष्टि की है और मंगलवार को इसकी घोषणा की गई थी।
And this one is speech to speech. The driver sustained serious head injuries. So here it shows the intermediate outputs as
ഡ്രൈവറുടെ
well.
തലയ്ക്ക് ഗുരുതരമായി പരിക്കേറ്റു.
சீனாவிற்கும் நேபாளத்திற்கும் இடையில் எவரெஸ்டின் உயரம் பற்றிய வாதம் 5 ஆண்டுகள் நீடித்தது.
माउंट एवरेस्ट की ऊंचाई को लेकर चीन और नेपाल के बीच 5 साल तक विवाद रहा।
You can also see that there's an option for rectifying the intermediate output and still continue with the rest of the pipeline there.
इसको हम इस प्रकार से समझें कि जैसे मानव शरीर एक है, किंतु उसके प्रत्येक अंग प्रत्यंग का अपना एक कार्य है और उस संपूर्णता में उसका अपना योगदान है। यदि कोई एक अंग कार्य नहीं करता है ठीक से, तो उसका प्रभाव केवल उस अंग तक सीमित नहीं रहता है।
न जानीमः। सामान्यतः वयं चिन्तयामः सुखम् अर्थात् अनुकूलं संवेदनं, दुःखम् अर्थात् प्रतिकूलं संवेदनम्। उदा
कई लोगों ने फरवरी की शुरुआत में कई हार्डवेयर इस्तेमाल करके खोज की पुष्टि की है और मंगलवार को इसकी घोषणा की गई थी।
कई लोगों ने फरवरी की शुरुआत में कई हार्डवेयर इस्तेमाल करके खोज की पुष्टि की है और मंगलवार को इसकी घोषणा की गई थी।
The driver sustained serious head injuries.
ഡ്രൈവറുടെ തലയ്ക്ക് ഗുരുതരമായി പരിക്കേറ്റു.
சீனாவிற்கும் நேபாளத்திற்கும் இடையில் எவரெஸ்டின் உயரம் பற்றிய வாதம் 5 ஆண்டுகள் நீடித்தது.
माउंट एवरेस्ट की ऊंचाई को लेकर चीन और नेपाल के बीच 5 साल तक विवाद रहा.
So I'll also quickly show the transliteration. I think the team already demonstrated it. So if you just quickly go to Ulka page, here you can see, you can select so this will show options as a type. Yeah, so basically, yeah. So this is what we would be integrating in the Shunya and Chitralekha platform as well. Coming back to the roadmap, so basically, so we are in the process of creating dataset schema and support for POS and NER, and also like for the multilingual and multi-speaker datasets as well. Recently, like it's catching up with the attention, so we wanted to support as soon as possible. Same thing with models. And coming to the benchmark, so we don't have any standard OCR benchmarks in Indic languages. So team is currently reviewing whatever is curated for all the 23 Indian languages is being under review. And there's a paper published around it, but we are just checking the feedback from other external teams as well. And of course, like there will be a mobile APK released shortly. And also like the expectation is like we are looking for models wherein we can get a real-time inference. So the interesting thing would be like STS, right? So that's what we are working with other teams to get their beautiful models in. And of course, like when it's open for public, so we wanted to capture user analytics, which shows like which are the popular data sets or models that's being downloaded or inferred. And also like as a part of this, like ready-made data sets would be created based on the popularity of the searches. And the next roadmap, because like we'll be creating all these data sets through various channels, we wanted those things to be converted in, or automate the process of converting into Ulka format and then having it submitted to Ulka as part of the chain itself.